Good evening, viewers. Welcome to my YouTube channel. We are going to look at a question on vectors. So that question item B is a question on vector. In the diagram, OA is equals to A, OB is equals to B, and X is a point on AB such that AX over XB is equals to over 3. Express the following vectors in terms of A and B. So for item 1 it's vector AB, for item 2 it's vector AX, and for item 3 it's vector OX. Now the solutions to our problems. So we have item 1. We want to calculate vector AB. So vector AB, we are now writing the root. This is vector AO plus vector OB. Now we are reversing the inequality, the direction sign. It's now minus vector OA plus vector OB. And vector OA is A, so we have minus A plus 2 vector B. This is vector AB. Now, number 2, vector AX. Vector AX. We are given in the notes there that AX over XB is equals 2 over 3. We want to find the ratio AX is to XB. So we do cross multiplication. This is 3AX being equals to 2BX. Now the ratio AX is to BX is 2s to 3, meaning that BX is 3 parts and AX is 2 parts. So to get AX, vector AX, we now say this is AX, this is AX. We now say 2 over total ratio, that's 5 of what? Of vector AB. And we've calculated the vector AB as minus vector A plus 2 vector B. So this is our vector AX. So that's now our vector AX. So item 3, for item 3, want OX, vector OX. This is vector OX. So vector OX, the root is vector OA plus vector AX. OA plus AX is the same as this vector OX. So OA is vector A plus vector AX, this is vector AX. So it's now 2 over 5 into minus vector A plus vector 2B. We simplify here, we have vector A minus 2 over 5 vector A plus 4 over 5 vector B. Then we simplify here, this is same as vector A over 1. Common denominator, that's what? Over 5. So 1 into 5, that's 5 times A, we have 5 vector A, minus 5 into 5, 1 times 2 vector A, we have 2 vector A, plus 4 over 5 vector B. This is equals to 5A minus 2A, that's 3 vector A over 5, plus 4 over 5 vector B. This is the value of vector OX. Now, next aspect, we are given the line OX is produced to C such that BC is equals 3A minus vector B. The lines OA and BC are produced to meet at D. Item 4, it is given that BD over BC is equals to K. Express BD in terms of K, A, and B. So we are saying OA and BC, this is where our C is. OA and BC are produced to meet at D. This is D. Now, it is given that BD over BC is equals to H. Now, I'm going to erase this diagram. So that we are saying BD as item 4 over BC is equals to K. And what it means, want to find vector BD. So our vector BD is equals to K vector BC, which is equals to K vector BC. For BC, we are given it as, if you go back to the diagram, it is given, it is said that BC is equals to 3 vector A minus vector B here. So this is 3 vector A minus B. So our B, this is our BD. So BD is now expressed in K, A, and B. Then for item 5, let's go back the instruction again. Item 5, given that OD over OA is equals to H, express OD in terms of H and A. So our OD over OA is equals to H. Now OD, vector OD is equals to, multiplying both sides by OA, it's H O A. Therefore our OD is equals to H times A. On the diagram there, OA is small letter a. So multiply the two, we have H vector A. So vector OD is equals to H vector A. We are done there. Then the last aspect, that aspect number 6, using the expression for OB, BD, and OD, form an equation connecting K, H, A, and B. Use this equation to find the value of K and H. So we are going to use the values of the equations to find the value of what? H and K. We are going to solve it simultaneously. So we have vector OB, vector BD, and vector OD. Right, if you check on the diagram there, for vector OB, this is vector OB, and also vector BD, and also vector OD. Meaning to say that vector OB plus BD is the same as vector OD. So we are equating, we are now equating, let me write here, that's V item 1. We are now equating vector OP plus vector BD. This is equals to vector OD. So on the diagram, let's go back on the diagram, check. Vector OB plus vector BD is the same as vector what? OD. And we have vector OB as 2A. So vector OB is 2 vector A on the diagram plus vector BD. This is our vector BD. We've calculated it already. So it's K into 3 vector A minus vector B. Then, which is equals to vector OD. This is vector OD on the whiteboard there. So it's equals to HA. Now we are going to use this expression to form two equations. We are going to use this to form two equations. Now let's simplify here first. 2 vector A plus, multiplying throughout by K, we have 3 KA minus KB being equals to vector HA. Now, this is equals to, sorry, this is vector 2B. Sorry, this is vector 2B, not 2A, it's vector 2B. Check on the diagram, it must be vector 2B. Now, we combine this vector and this vector. We have 3 vector KA plus 2 vector B minus K vector B is equals to vector HA. Is equals to H vector A. Our H and K are scalars, those are constants, they are scalars, right? This is 3 KA plus, we factor out B, 2 minus 1 minus K vector B is equals to H vector A. Now we combine those with vector A, then we combine them, and those with vector B, we combine them to form two equations. So combining terms in vector A, this is 3K is equals to H. This is our equation 1. But just like comparing coefficients of A. The coefficient of A is 3K, the coefficient of A is H. So we form this equation, meaning this 3K is equals to H. Then comparing coefficients of B, we now have 2 minus K is equals to, here there's no P, so it's equals to 0. This is equation 2. This is a simple simultaneous equation. We can use equation 2 to find the value of K. So using 2, we have 2 minus K is equals to 0. Therefore 2 is equals to K, meaning the value of K is 2. Now use equation 1 to find the value of H. So using equation 1, which is 3K is equals to H, and the value of K is 2. So we say 3 into 2 is equals to H. Therefore 6 is equals to H. Therefore H is equals to 6, K is equals to 2. These are the two values of H and K. So this is the case. So we must be very careful, especially when we are dealing with vectors, especially the direction. The direction is very, very important. You need to check the arrow, then where there's minus, put a minus, and where there's a positive, just put a positive. So thank you very much, viewers, for watching. Meet tomorrow, where we are going to look at some functional graphs and also traffic graphs in preparation for our November 2024 paper 1 and 2 mathematics. That's 4004 paper 1 and paper 2. Wish you the best. Thank you for now.